We've been learning about radian angle measure. And before we start talking about trig functions, we need to talk about how you would sketch an angle in radian angle measure in standard position. So if we start with a coordinate axis, remember when we're measuring angles, this ray that points to the right is our initial ray. So when we want to sketch an angle, we're always going to start there. So let's say I have the angle 27 pi over, I don't know, let's say 3. Now that's too easy. 4. Okay? 27 pi over 4. Now remember, one full rotation is 2 pi. So a half a rotation is pi. So when I see an angle measure like this and I want to sketch the angle, the first thing I want to do is figure out how many pi's is it. So I'm going to think of this as 27 fourths times pi. Well, 4 goes into 27 6 times, that's 24 fourths, with 3 left over. So that's 6 3/4 pi's. That means I'm going to go halfway around this 6 3/4 times. And since the angle was positive, I'm going to go in the positive direction, which is counterclockwise. So starting from here, 1, 2, 3, 4, 5, 6, and then the 3/4, remember it's 3/4 of halfway, would take me to here. So this is how you would sketch the angle 27 pi over 4. But when we start thinking about trigonometric functions of these things, we want to relate it to an angle that is an angle that we're more familiar with, one that would be between 0 and 90 degrees, or 0 and pi over 2. Remember, we talked about this last week, how you would go around here and label the values. So when we do that, when we have a terminal ray in any quadrant, we always look at the angle between the terminal ray and the closest side of the x-axis. And we call that angle the reference angle, and we usually use the Greek letter alpha to represent that. So our angle, theta, is 27 pi over 4, but its reference angle, alpha, if we go back to how we counted this, remember this was starting from the 0, this was 3/4 of pi, so I need another 1/4 of pi to get to the x-axis, so this would be pi over 4 in this case. When we want to find a trig function of an angle that's not a regular acute angle in the first quadrant, we relate it to an angle that would have been in the first quadrant by dropping a perpendicular line from a point on the ray down to the x-axis, always to the x-axis, to form a right angle. And then this forms a triangle. Now, the coordinates of this point, we're just going to say those are x and y. If that point were in the first quadrant, x and y would both be positive numbers. And they would actually be the lengths of the sides, because the length of this side is the absolute value of x. And the length of this side is the absolute value of y. The length of the third side, we would call it the radius of the circle, but it's the hypotenuse of this right triangle. So the radius is the square root of x squared plus y squared. And you don't need the absolute values there, because when you square them, you get a positive answer anyway. So if I were looking at this 27 pi over 4 angle that went around and around and around, I'm going to relate that to its reference angle, alpha. And I can use our Sohcahtoa angle ratios So if I were thinking about this angle alpha, the sine would be the opposite over the hypotenuse, so that would be the absolute value of y over r. And our cosine would be the adjacent over the hypotenuse, so that would be the absolute value of x over r. And the tangent would be the opposite over the adjacent, which would be the absolute value of y over the absolute value of x, if we were talking about alpha. But since we're talking about this other angle, and these numbers, these x's and y's, aren't both negative, in order to make it the correct trig values for this angle that is not in the first quadrant, we use the signs of these values. So in this particular quadrant, x would be negative and y would be positive. So when we do our trig ratios for other rays that don't have their terminal point or a point on their terminal ray in the first quadrant, we don't use the lengths of the sides of the triangle, we use the coordinates of a point on the ray. So our point on the ray is xy. The radius is going to be the square root of x squared plus y squared. And since we're looking at it, since our angle is always centered at the origin and uses the x-axis as one of its sides, the x is always going to be the adjacent side, and the y is always going to be the opposite side if you're relating it to our trig ratios. So the sine of an angle is y over r. The cosine of an angle is x over r, and the tangent of an angle is y over x. This is how we define the trigonometric ratios for angles that are not between 0 and 90, that are not within a right triangle. And then, of course, the reciprocal functions. The reciprocal of sine is cosecant, so it would be r over y, and the secant would be r over x, and the cotangent would be x over y. So with that in mind, that means that our trig ratios sometimes will have negative values. When we did ones that were in a triangle, since we were always using lengths that couldn't be negative, we couldn't get any negative values. But since the coordinates of a point can be negative, we will get some negative values. So it's also important to understand what trig functions have positive and negative values in which quadrants of our graph. So in our graph, in the first quadrant, both x and y are positive because you go to the right and up to get into the first quadrant. In the second quadrant, you go left and up, so your x coordinate is going to be a negative number and your y coordinate is going to be a positive number. In the third quadrant, you go left and down to get into the third quadrant, so both your x and y coordinates are going to be negative. And in the fourth quadrant, you go right and down to get there, so your x is positive, but your y value is negative. So when the terminal ray is in one of these quadrants, the x and y values are going to have these signs as indicated by which quadrant they're in. But the radius is always considered to be positive. It's the distance from the origin. So if the radius is always considered positive, then looking again at your trig ratios up here, if r is always positive, then when y is negative, sine and cosecant are going to be negative. When x is negative, cosine and secant are going to be negative. When x and y have the same sign, either both positive or both negative, tangent and cotangent are going to be positive. When they have opposite signs, they'll be negative. So, looking in quadrant 1, x and y are both positive, r is positive, so all trig functions will be positive when their terminal ray is in the first quadrant. In the second quadrant, x is negative, y is positive. So the things that have x in them are going to be negative. That's everything except sine and cosecant. So all of these other ones are going to be negative, but the sine and the cosecant are going to be positive. So in the second quadrant, sine and its reciprocal are positive, and all the rest of the trig functions are negative. In the third quadrant, both x and y are negative. Well, that means the ones that have either x or y with r are all going to be negative. But the ones that have x and y together, since you have a negative divided by a negative, will be positive. So in the third quadrant, tangent and its reciprocal are positive, and all the rest of the trig functions are negative. And in the fourth quadrant, when x is positive and y is negative, then the ones with y in them are going to be negative, and the ones with x in them without y are going to be positive. So cosine and its reciprocal will be positive in the fourth quadrant, and all the other trig functions will be negative. So to help us remember, we always start with the upper right-hand quadrant and go counterclockwise when we're labeling them. So A for all trig functions being positive, S for sine and its reciprocal being positive, T for tangent and its reciprocal being positive, and C for cosine and its reciprocal being positive. And a little phrase to remember this is all seniors take calculus. So if you can remember that little phrase, and remember that A means all trig functions are positive, S means sine and its reciprocal are positive and the rest are negative, T means tangent and its reciprocal are positive and the rest are negative, and C means cosine and its reciprocal are positive and the rest are negative, going by quadrants, then that'll help you remember whether to use a positive or negative value for those trig functions. So moving on from that background, when we want to find the value of the trig function of an angle, the general process is to first sketch the angle in standard position, because you need to know in which quadrant its terminal ray lies. Then you're going to decide, okay, it's in a certain quadrant, and you're going to find its reference angle. The reference angle is always the angle between the terminal ray and the closest side of the x-axis, and that angle will always be between 0 and 90 degrees, or between 0 and pi over 2 radians. If its reference angle is one of these standard angles, remember 30, 45, 60 were our special angles from geometry, and 0 and 90 are pretty special themselves because they lie on the axes. If its reference angle is one of these, then the trig function for the angle you started with will have the same absolute value as the trig function of that particular reference angle. And then you just change the signs depending on which quadrant it lies in. So first of all, we did talk about what the trig values were for these special angles in a previous lesson, but there's a way to make a chart to help you remember what the trig values of these various angles are. And it's handy to remember how to make this chart until you get to the point where you have the trig values of those angles memorized. So here's the process for making this chart. You start by putting the labels for the chart, sine, cosine, tangent, in that order down the side, and our special angles starting with 0 and going up to 90 degrees or pi over 2. Now remember, our 30, 45, and 60 are all nice fractions of 180, which is pi. So 30 is 1/6 of 180, so its radian angle is pi over 6. 45 is 1/4 of 180, so it's pi over 4. And 60 is 1/3 of 180, so it's pi over 3. Now, to get the trig values, for the first row, you count from 0 to 4, take the square roots, and put them over 2. So the square root of 0 is 0. over 2 reduces to 0. Then 1, square root of 1 is 1 over 2 reduces to 1/2. 0, 1, 2, the square root of 2 over 2 doesn't reduce. 0, 1, 2, 3, the square root of 3 over 2 doesn't reduce. 0, 1, 2, 3, 4, the square root of 4 over 2 reduces to 2 over 2, which is 1. So the sign of 0 degrees or radians is 0. The sign of either 30 degrees or pi over 6 radians is 1/2. The sign of 45 degrees or pi over 4 radians is the square root of 2 divided by 2. The sign of 60 degrees or pi over 3 radians is the square root of 3 over 2. And the sign of 90 degrees or pi over 2 radians is 1. So for the first row, for the sine row, you count from 0 to 4, taking the square root, and put it over 2, and that gives you the values of the sines of the special angles. Now the cosine row is just the sine row backwards. So instead of starting with 0 and ending with 1, we're going to end with 0 and start with 1. So we just copy that first row, but going backwards. And the tangent row is the sine divided by cosine, because sine, remember, was y over r. Cosine was x over r. When you divide two fractions that have the same denominator, you just divide their numerators. So 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 is 1 over the square root of 3. Or if you don't like the radical in the denominator, you can rationalize that to the square root of 3 over 3. The square root of 2 over itself is 1, because anything over itself is 1. The square root of 3 over 2 divided by 1/2 is just the square root of 3. And 1 divided by 0, well, division by 0 is undefined. So that's undefined. And those are the values of the trig functions of all of these special angles. So now, if I want to find the exact value of the 6 trig functions of a particular angle, like this one, for example, this is known as negative 31 pi over 6. So the first thing I'm going to do is I'm going to reduce 31 pi over 6 to a mixed number. It's still negative. 6 goes into 31 5 times, with a remainder of 1 put over the 6th, and that's multiplied by pi. So that means I'm going to go 5 1/6 times halfway around, because pi is halfway around, in the negative direction. So that means I have to go clockwise. So starting with my initial ray, which is to the right, I'm going clockwise. 1, 2, 3, 4, 5, and then about 1/6 of the way from here to here would be about 1/3 of the way from here to here. So that would be there, and this would be my terminal ray. Now, my reference angle is always the angle between the x-axis and the terminal ray. So my reference angle is just this piece right here. Well, remember I counted 1, 2, 3, 4, 5, and this was 1/6 of pi further. So this angle is pi over 6, and that is the reference angle for this angle, negative 31 pi over 6. So our angle x is negative 31 pi over 6, and its reference angle alpha is pi over 6. So I'm trying to find all 6 trig functions. So this is the most tedious part, in my opinion, just writing that I'm taking the trig functions of that angle, all 6 of them. Now, I have to think about the quadrant. So looking at this ray, it is in the second quadrant. second quadrant means that the sine and the cosecant, its sine and its reciprocal, will be positive, and the values of all the other trig functions will be negative. So before I even start thinking about a number, I'm going to put negative signs for all the rest besides sine and cosecant. And then, since I figured out that its reference angle was pi over 6, I just look at my chart. The sine of pi over 6 is 1/2. So the sine of negative 31 pi over 6 is 1/2. The cosine of pi over 6 is radical 3 over 2. So the cosine of negative 31 pi over 6, since it's in the second quadrant where cosine is negative, is negative radical 3 over 2. And the tangent of pi over 6 is square root of 3 over 3. So, since we're in the second quadrant, the tangent of negative 31 pi over 6 is going to be negative square root of 3 over 3. And then to find the values for the reciprocal functions, I just take the reciprocals of these numbers. So the reciprocal of 1/2 is 2 over 1, which reduces to 2. The reciprocal of negative radical 3 over 2 is negative 2 over radical 3. And if you don't like the radical in the denominator, you can rationalize it by multiplying by the square root of 3 over itself. So the secant would be negative 2 square root of 3 over 3. The reciprocal of the tangent would be negative 3 divided by the square root of 3. Well, negative 3 divided by the square root of 3 is just the square root of 3. So you sketch the angle so you can figure out which quadrant its terminal ray lies in. That determines whether the sines, cosines, tangents, and so on are positive or negative based on our ASTC that we discussed. And you find how big its reference angle is, and then you just use the values from the chart to find the values of the trig functions. Okay, one last example. So if I want to find the exact values of the trig functions of 29 pi over 4, first thing I'm going to do, 4 goes into 29 7 times with 1 left over. So this is the same as 7 and 1/4 pi. This angle is positive, so I'm going to go in the counterclockwise direction. So starting at the initial ray, 1, 2, 3, 4, 5, 6, 7, and 1/4 of halfway would take me to here. So we are in the third quadrant. And in the third quadrant, remember that was T, that means tangent and its reciprocal are positive and all of the other trig functions are negative. Now, when I was going around and around here, I had gotten up to 7, so this reference angle is pi over 4. So that means the numbers I'm going to use for my trig functions are going to come from the pi over 4 column of the chart. So again, I have to write, if you're going to know which answers for which question, you need to write all of these out. And remember, don't get confused between secant and cosecant. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. It's a little bit counterintuitive. Now, we already said tangent and its reciprocal are going to be positive, and all the rest of the trig functions are going to be negative. And now we just look at the values for pi over 4. Well, for pi over 4, the sine and cosine are both square root of 2 over 2, and the tangent is 1. So down here, I have the square root of 2 over 2 for both the sine and the cosine, except they are negative for this angle. And I have 1 for the tangent. Then to find the trig functions of the reciprocal functions, I take the reciprocals. So this would be negative 2 over the square root of 2, which simplifies to negative square root of 2. And this would be the same, because it was the same over here. And then the reciprocal of 1 is just 1.